Hi, this is Neal with the HC Library, and in this video, we're going to be going over the basics of chemical bonding. Let's get started by laying a foundation of terms and concepts and answering the question, what is an atom? Alright, so an atom is made up of three parts, and it essentially is a particle that uniquely defines an element. Now, how does it do that? Well, that brings us to the first part of the atom. It's what's called a proton. Now, protons have a positive charge, and as I said, they define the element, what element the atom will be. So, whatever number of protons an atom has, that tells you what element it will be. So, for example, one proton is hydrogen, two protons is helium. Now, let me switch my little color, and we'll go to the next part, which is the electron. The electron is has a negative charge, and it orbits in rings. There's multiple rings of electrons, and it orbits around the atom, and it allows for bonding, and it cancels out the charge brought on by the proton. It's very important. We're going to get into them later. The final part is called the neutron. It has no charge. It's neutral, no charge, and it serves to keep the element together, keeps the atom together. And let's take, for example, this helium atom. We know it's helium because it has two protons. Those two red bubbles, those are protons, positive. Two protons in an atom means that atom is by definition helium. Then we see two neutrons. So there's two blue circle spheres, what do you want to call them? Neutrons. And it has two, and this only shows the outer ring, which is usually considered the most relevant ring when talking about atoms. So the outer ring of electrons called valence electrons. Now there's two valence electrons in helium. There's always going to be two, and they cancel out what is brought on by the protons. Now, moving on, I'd like to touch up on the periodic table. So the periodic table is a collection of all known elements and organizes them in these really interesting ways. And so we go hydrogen, helium, lithium, beryllium, and on the top it shows you the atomic weight, so it tells you the protons, neutrons, it tells you all about these elements. And for this video, we're really not going to focus on this interior part. Those are the metals. We really don't deal with them right now. We're going to do mostly gases and reading those structures. And interesting about the periodic table is that it actually tells you how many valence electrons a element will have by just its location. So for example, everything in the first column, hydrogen, lithium, sodium, all they have one valence. And everything in the seventh, they'll have fluorine, chlorine, they all have 7 valence electrons. Right, but one little thing, let me switch my color. One thing we want to watch out for is helium. It's only has 2 valence electrons, so it doesn't follow that rule of being in the last line. Now, I'd like to get into why atoms bond. Now, atoms bond because of something called the Octet Rule. Now, as its base suggests, the Octet Rule states that atoms want 8 electrons, and they want that for stability. Now, the problem arises where, let's take, for example, carbon. It only has 6 valence electrons. So how does it get 8? Well, it reacts with other elements in order to gain electrons, right, in a process called bonding. Now, let me get into bonding. So, in its most basic form, generally, there's a lot of types of bonding, but the two most basic forms of bonding that we're going to be going over in this video are ionic bonding and covalent bonding. So give me a second to write that down. So ionic bonding is where we're going to be sharing, it's going to be transferring electrons. So one atom has 7 electrons, one atom has 1, that atom gives its electron. And that's how you create ions or charged particles, because you're giving away your electrons. In covalent bonding, however, we're sharing electrons. So an electron is fusing, and it's really going around, it's working with 2 elements instead of 1. Now, the end result of both of these is to satisfy the octet rule. And then again, that means 8 electrons. So they're both working to get either 8 or 0 electrons to keep the element stable. So that's what we're gonna go over covalent bonding in this video. So an example of covalent bonding. So a really good, strong example of covalent bonding lies in water, actually. It's water. So we know that water, the chemical compound, the formula, the combination, whatever you want to call it, of water is H2O, right? And what does that mean? So the subscript, that little number beneath the element, states how many of that element we have in the compound. So since there's a 2 under the hydrogen, it means there's 2 hydrogens. And since there's nothing under that, we assume it's 1. So we don't write 1 because there's no 1, you just know it's 1. And so there's 1 oxygen and 2 hydrogens in water. And what I'm doing right now is what I'm drawing is called a Lewis dot diagram. It's basically just the element name and the number of valence electrons it has. Also, note that another exception, like the exception with helium, lies with hydrogen. It can only have 2 valence electrons. It does not want 8, it wants 2. It can only accommodate 2. That's the number of valence electrons it has, and so it does not follow the octet rule in the traditional sense. Oxygen, however, does, and it has 6 valence electrons, so it needs to add 2 more, and what we see is a perfect example and opportunity for covalent bonding. So this hydrogen, each of the hydrogen atoms are going to go, and they're going to go bond with the oxygen. We're going to put that in red, and the oxygen will then be bonded with the 2 hydrogens, and it will have satisfied its octet. And there you go, that's covalent bonding in a nutshell. So, what have we learned in this video? So we have gone over atoms. We've gone over the 3 parts of atoms: protons, electrons, and neutrons, and what they sort of mean for elements. We've gone over the periodic table, which is just the consolidation of all the known elements. And people have found new elements in the past few years, so keep your eyes peeled for that. We've gone over the Octet Rule, which is really, really important for bonding in chemistry. And we have gone over just bonding itself, the 2 types of bonding, ionic and covalent bonding. And in a later video, we'll go over ionic bonding, but right now I want to focus on covalent because that leads us into the next video, and keep your eyes peeled for that. It is on chemical diagrams, how to read them, what do they mean, because they can get really complex, and there's 3 types of them. And finally, I would like to say thank you so much for watching this video all the way through. This has been Neal with the HC Library, and thank you really.